I'm gonna make at least one nut and show it in real time so that you guys can see how long it really takes to make one of these nuts. So many times with YouTube, there's splices in the footage and you really don't know what's going on to make that footage. So I'm gonna start out with my first nut. I'll probably practice one time, and then the second nut, I'm gonna make it in real time with the camera flowing and let you see what we're looking at and any mistakes that I might make. But so here goes the real time video. And then stick around afterwards and we'll break it down for you. Okay, to give you an overview again, you can see the frame of the locomotive here. This is the bolster that holds the axle, so the axle can move up and down. And this is the suspension system that we're working on right now. We've already had a video where we've explained making the springs. So we're going to move on to the nuts in this video. I need 16 nuts. These are little small stainless steel nuts with a 1/8-40 thread pattern. So let's get to it. Huh. Okay guys, here's going to be the breakdown. It's raining outside the shop, which is a great day for me personally to do this video. Probably not the best for the audio, and the lapel mic hasn't come in yet, so stick with me. But just breaking it down, the first thing is that I'm using a collet chuck, and it's got a hex pattern in it, so you can hold hex bar. This is stainless steel hex bar of the appropriate size for me. That makes it a lot easier than trying to machine the flats. You can machine the flats, and I do machine the flats, but if you're gonna make 16 nuts, you're not wanting to machine all those flats. So you buy the hex stock, and it works out really nice. Get you a hex collet to go with it, and you'll speed your assembly, your manufacturing process up quite a bit. It's also stainless steel, and stainless steel has some unusual properties. It's good about not corroding on you. It can corrode if it has impurities in it, and anybody that's had a boat knows that. You will get some little small rust pits in stainless steel from the impurities that are rusting out. But in general, it doesn't corrode, and that's the benefit of it. From a machinist standpoint, the drawback is it machines pretty good as long as you keep the tool cutting. It's a drill bit, it's a cutting tool, if it's a parting tool, whatever you're using, you've got to keep it cutting. As soon as that tool rubs on the stainless steel without cutting, it'll heat it up, work harden it, and then until you get back past that work hardened area, you'll have trouble. So you'll notice in the video that once I engage the stainless steel, I keep my tool engaged, or I pull it out, withdraw it to lubricate it, and then re-engage it. Especially with the drill bits, these small drill bits where you have to do some pecking to keep the flutes clean. You cannot let the flutes pack up with the chips, or you'll break these little bits. So you get in there, drill, get back out, lubricate it, clean it, lubricate it, get back in and drill, back out, clean it, lubricate it, back in. And I drop my headstock into low gear. I do not put it in the back gear, so it's not the lowest speed, but it's the lowest speed that the high-speed gearing will provide. With my bigger taps, I'll drop it into back gear as well, because you need that drag to be able to turn your tap without turning the workpiece. But with these little small taps, I like for it to have a little springiness to it, so that if the tap starts binding, I can see the collet starting to turn, and then I know I need to stop what I'm doing with the tap and back it out. And with these little nuts, if you can't go as deep as you think you should be going, that's fine. As long as you got 2 or 3 threads started, you can part that nut off, take it over to your vise with your, hopefully with your copper jaws, and squeeze that nut in there and tap it when it's by itself. So these nuts are 1/8 of an inch tall, and that tap's going to be driving the chips forward if you're using a gun tap like I am. And so if you can get that little nut parted off and off by itself, it'll tap very easily. But when it's ganged up here, like if you're trying to drill and tap enough for 4 or 5 nuts at once, you might in fact you will run into problems. Your chips are pushing forward, your tap's getting a lot of friction as it gets deeper and deeper, and you're going to break that tap, and then you got real problems. You have to cut your stock off and start again. It's very difficult to get a tap out. So that's a little advice on working with stainless steel. So what we did, we used a center drill, and I marked my center. Now this one right here that I had is actually for doing a center in a workpiece where you're going to put a live center in or a dead center. And so, but I do have a sure enough little starter drill bit that's got a different angle on it for starting your drill bit. And I should have grabbed it. I just the video was going, I grabbed the first thing that my hand landed on. But this is a number 38 drill, and that's the drill size for a 1/8-40 tap. That's a little bit of an unusual thread pattern, but 1/8-40, which is very close to a 5-40. 1/8-40 is what my plans call for, so we use the number 38. Another tool you saw used was this tap follower. This is something that I made. It's got a cap piece here that's threaded on, and there's a spring in here, and then this moves. And so what that does, I bring my tailstock up, it engages the little hole that you have in the end of your tap wrench is designed for that. So it engages it, and what that does is keeps my tap straight when it engages the stock. Otherwise, the taps wobble, and a couple things can happen. You can tap it crooked. Generally, as it goes in, it's going to straighten itself up. But as it does that, you can imagine it's cutting in a curved plane, so it's going to make those first few threads larger than they need to be and would otherwise be, and you wind up with a looser fitting nut. So if you can get that thing started dead center and take it in that way, you're going to have more precision, and this is one way of doing it. So this is a 1/2 inch, which is right what'll fit into my chuck and my tailstock, and then I bring the tailstock up, the pressure on the spring, which allows the tap to engage with a little pressure, start running it in. And if it's a long threaded hole, it won't be with a small tap, but if it is with a big tap, I want to, once I run out of spring pressure, I'll bring my tailstock even further forward and engage it again. One thing you've got to remember is when you start backing this tap out, you don't want, it's going to compress this tailstock, this spring, and you don't want to let that happen to the degree that you start stripping out your threads in the nut. That can happen. So as you start backing it out, you're better just to get the tailstock out of the way and then back it out, and that way you make sure you don't strip your last few threads due to it binding on you as it comes out. My little nut, I tried to catch it with I think this is something my wife had left over from years ago when we painted a nativity scene back in the days when everybody would do pottery. And but I used it, stick it up in the nut and hopefully let it fall off, and that generally works. But of course, in the video, I dropped the nut and did what all good actors do, and I fell back on the practice nut I had done. But I did eventually find the nut that I dropped. Let's see, any other techniques? A lot of people worry about parting off. And I frankly haven't had any difficulties with it. This is a very thin parting blade, and I chose that because I don't want to waste my stock. If I'm cutting off 16 nuts and I use an 1/8 inch blade, I'm going to wind up losing a lot of stock to chips. So this is a 1/16 inch blade, and in order to make it work in my tool holder, I had to put a spacer in here, and that brings the width up to what my old blade, my thicker blade is, so that I don't have to keep adjusting my own center height. So how do you make this thing work good? You got to find the appropriate speed, and it's different for different materials. For this stainless, I find that it likes to run a little bit faster than with brass. So right now, I'm running in my low gear, I'm in B, and in my high gear, I'm in C. So if I come up here and I look at B and C, I'm running at 139 RPMs for this. And then it's got to be perpendicular to your material. So make sure that you align it with your headstock so that it's perfectly perpendicular, or else you'll cut a cone and you'll get a lot of friction and binding on whichever side is getting the pressure. So perpendicular, I lube it with just some of my tap lube, and once I engage, it's just a steady pressure as you advance the carriage into the work piece. If you need to pause for a minute, make sure you back it back out, or you're going to work harden your stainless steel as this is rubbing and creating heat through the friction. But that's the way I do it, and it's always worked good for me. If I'm getting chatter, then I probably don't have this adjusted vertically properly. I'm on a center line, or I'm running my material at the wrong speed, or something that's even more common is I don't have this blade tightened enough, or I've got too much stick out. So let's say we're cutting off a 1-inch piece. We're going to need a thicker blade that can handle more stick out, so we can get to the center of that work piece to part it off. But these little nuts are that's a very, very small diameter on that work piece. I only need to go in the radius, so I can have a short stick out, which helps in my rigidity and keeps me from getting chatter. Then there's one more thing that I want to show you. I'm gonna have to take the camera down, but you saw me adjusting a stop down here. It's a stop that I made a few weeks ago. I wish I'd filmed it. If you guys want to see one of these made, we can make another one. But it's a stop with a dial indicator on it, and I have to adjust that stop so that the throw is in the right position. But the carriage, as it comes back, it hits this plunger. And so I was measuring you saw me measure where my cutoff tool was in relation to the end of my stock using a feeler gauge. So I just make those smooth with each other, because I know this side of the parting blade is going to determine the back side of my nut. So then once I have it smooth, I move back 1/8 of an inch, 100.125 on my dial indicator, and then I locked my carriage down and started parting it off. And that brings up another good point. You want to have your carriage locked down when you do your parting off. You do not want to just attempt to hold it with your hand. Once again, you'll cut a radius on the front of that on that workpiece as you part it off, which is not what you want, and it's damaging to your blade. It creates so much friction, you get more heat. That's breaking down that little section, and then we'll break down doing the studs and the little washers in a minute. Thank you. All right, guys, there's my 16 nuts, and I hope you remembered your loved ones on Valentine's Day this year. Thanks for sticking around to the end. And remember, hit that subscribe button.